Hi class, in this video I'm going to talk about two shortcuts for proving triangles are congruent. So this is kind of a follow-up to how we had to use the definition of congruent triangles to prove triangles were congruent, which meant we had to show that every corresponding angle was congruent and every corresponding side. Now that's kind of a long process, so we actually have some shortcuts that work out for us. The first two we're going to look at in this video are called side, 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 and side, angle, side. So we're abbreviating those this way. Side, side, side is SSS. Side, angle, side, SAS. What this means is if I can show all three sides are congruent, corresponding again, that's enough to show that the three triangles are congruent. This is a postulate that we have in geometry. So in this picture here, I'm given DC and AB are congruent, and I'm given BC and DA are congruent, and then I also know that AC is congruent to CA because it's the same side, it's reflexive. So I can say that triangle ABC is congruent to CDA by the side, side, side postulate. Okay? Side, angle, side means I have two sides that are congruent and I have an angle between them that is also congruent. So I have two separate triangles right here. I've got AB is congruent to BD. I've got this part of B, the angle is congruent to the bottom part, and again I've got a shared side. So in each triangle I have side, angle, side, side, angle, side. So since it's in both triangles, that's enough to say that triangle ABC is congruent to DBC by the side, angle, side postulate. Okay, so we're going to use these shortcuts to show some triangles are congruent. Okay, so in example 1, we're showing the triangles are congruent for the given value. So are they congruent for x equals 18? So remember what needs to happen. I've got one shared side here. So RT is congruent to TR. I've got this angle needs to also be 36. And then this side needs to also be 61. So that I have side, congruent angle, congruent side. So if I plug in for UT, and I've got 4 times 18 minus 11. And then I'm also going to do the angle, so 2 times 18 for the measure of angle UTR equals 2 times 18. So we want to hopefully show that this one is 61 and show that this one is 36. So 2 times 18 is 36, so this angle also works out. And then if we check out that top one and we do 4 times 18, I get 72. 72 minus 11 gives me 61. So we can say that those two triangles are congruent. Triangle ST is congruent, triangle RST is congruent to triangle TUR by, and this was side, angle, side, and this side's also the same, side, angle, side. And actually something that might be a little bit helpful, you guys, is to use some different colors to kind of show. So let's see if I can get a couple different colors going here for you. Make that a little bit easier to see. Okay, so for example, this side corresponds to this side, and we showed they're both 61. This angle corresponds to this angle because we showed they're both 36. And then my last side corresponded to itself, so side, angle, side, and that's where we can see that show up. Okay, so we're going to use one of our shortcuts in this number 2 to show that triangles are congruent. So we're going to prove that these two triangles are congruent, and I'm going to use one of my shortcuts. So I'm told that these are 4 and these are 3. So since I know that, that's given to me in my diagram, I can say that BC, and you notice B and E correspond to each other, so BC corresponds to ED. I can say that those are congruent because they're both 4. And remember, if segments have the same measurement, they're congruent by the definition of congruent segments. And I have the same exact thing happening here with CE and DB. Same thing, definition of congruent segments. They both are equal to 3 inches, so they're congruent. Now I need a third side. I've got two sides, or I need an angle in between. Well, I don't know anything about the angles that's given to me, but I see that I've got a shared side. This side is congruent to itself. CD is congruent to DC, and that's the reflexive property whenever we say something is congruent to itself. So I have side, side, side. Here, I've shown 3 different sets of sides are congruent. So triangle BCD is congruent to triangle EDC by the side, side, side postulate. Okay? All right, let's try a couple more here. All right, number 3. We are kind of given a partially filled out proof, and I want to fill in the rest. Okay, so we're told that B is the midpoint of DC, and that AB is perpendicular to DC. We want to prove that ABD, this left triangle, is congruent to ABC, that right triangle. Okay, B is the midpoint. That was something that was given to me. Now, what can I take away from that? So I'm going to use that definition to tell me something else about the picture. Well, midpoint means it's exactly halfway in between, which would mean that this half is exactly the same as this half. Sorry, that looks like 2. So I'm going to put a tick mark on each of those so I can say that DB is the same as CB from that definition. Okay? All right, now we are going to use another given. So the only other given I have is that AB was perpendicular to DC. Okay, and this next part is ABD and ABC are right angles. So they're telling me both of these are right angles. This one was already marked, but this one wasn't. So really the reason I know that is actually from this piece right here. The fact that they're perpendicular means they're intersecting at 90 degrees or at right angles. So I'm actually going to say that that's from the definition of perpendicular. Okay? It means they're intersecting at right angles. Now they're telling me angle ABD, so this one right here, is congruent to ABC, this one right here. Well, if they're both 90 degrees, then they're congruent, right? If they have the same measurements, so definition of congruent angles, they're both 90, so they're congruent. Now I'm going to use the reflexive property. Remember, reflexive is saying something's congruent to itself, which almost always happens as a shared side when we're doing these problems. And I notice AB is in both triangles, so I can say AB is congruent to AB. And in this one, you guys notice I didn't change the order because A is the top of both triangles, so it corresponds to itself. All right, so let's see what I have here. I've got a side, an angle, and a side in this left one. And over here, I've got matching side, angle, side. So that's what shortcut is being used, the side, angle, side postulate. All right, last one here, guys. I'm not going to complete this one in its entirety, but I will get you started. It says use the distance formula and side, side, side to determine whether the triangles are congruent. So I've got triangle ABC and DEF. And from the order that they put them in, I know A and D correspond, E and B, F and C. So I want to show, using side, 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 that these, well, they might not be congruent. They're telling me to decide whether or not they are. I'm asking, is AB equal to DE? Is BC equal to EF? And is AC equal to DF? So I'm asking, are those corresponding sides equal? If they are, then I can say, oh, the triangles are congruent using that side, side, side. So how do I determine if these are equal? Well, they did give me some coordinates. 2, 3, 3, negative 1, 7, 2. D is at negative 3, 1. E, 1, 2. And D, F, negative 3, 5. So I can use the distance formula to find the distance between those. So distance formula, remember, is square root of y2, or I'll do my x's here. x2 minus x1 squared plus y2 minus y1 squared. So I'm just plugging in those numbers here. So for AB, the distance or the length of AB, if I plug in those right numbers, I would do x2 minus x1. So I've got 3 minus 2 squared plus, do the same thing with my y's, negative 1 minus 3 squared. And then it's just a process of simplifying. So we've got 1 squared plus negative 4 squared, which equals 1 plus 16, which is the square root of 17. And if we take the square root of 17 here, I get 4.12 if I round to the nearest hundredths. So the distance of AB is about 4.12. Now I would repeat this exact same thing for ED and see if they were the same. If they were, I could say that this side was congruent to this side. And then I would keep moving. Then I would check BC's length compared to EF's, AC's compared to DF's. If they're all the same, then I have congruent triangles. If I find any correspondings that don't match, let's say I got 4.12 for this side, and I got 5 for this one. There's one side that doesn't match corresponding. That means they're not congruent, and I wouldn't have to keep going. Okay, so that's how you can complete that problem and use the distance formula to help you determine if all the sides are congruent. All right, guys, there's 2 shortcuts for you that will save you a little bit of time and not have to use the definition of congruence to prove triangles are congruent. Thanks for watching.